And just before we start remainder theorem, just something very, very simple to do is how to change between a factor and a root. But that's really, really easy to do. Like for example, if I said x plus 1 is the factor, what would be the root?
X equals minus 1.
Minus 1 would be the root. And likewise, if I said x equals 1 is the root, then what would be the factor? X minus 1. So that's just some basic switching of the two. But you need to be careful in the exam because sometimes they say factor and sometimes they say root. So if you mix them up, you might not get full marks, okay? So just be careful the difference between factor and the difference between root. So this is a factor, but this would be a root. And for example, if this is the factor, what would be the root? Minus 3 over 2 would be the root. Okay, so just please be careful with those two words. That's okay. Alright. So let's have a look now at the remainder theorem. Okay, so if you can write this down, we'll have a look at this now. Right. Thank you. Last time we saw how to do a long division. If we have a cubic, like ax cubed plus bx squared plus cx plus d, and we take this cubic and we divide it by x minus, let's just say k, we can find the remainder. But this is a very, very long way to find the remainder. It takes some time and you could make a mistake. So we want to know, is there a formula to find the remainder? So is there a quick formula we can use to find the remainder? So let's try and find this formula. So we have x minus k, whatever the k is, divided into some cubic. Ax cubed plus bx squared plus cx plus d. So before I start, just to explain what we're trying to do. What we're trying to do is to end up with some formula down here that will give us a formula for the remainder. Yeah? Okay. Right, so can you write this down and we'll start the long division together then. So the very first one is not so difficult. What do I need here? It's going to be ax squared. And that's okay, so that's the first one. So that will make ax cubed minus ak x squared. So again, that's okay so far. We minus, these cancel as normally as the case, and here we have to be careful. Minus minus makes plus, and actually we end up with b plus ak x squared. So that's okay. It's a little bit bigger, but it's still the same idea as last time. Yeah. So next one has to be b plus ak x. We multiply and we get, oh sorry, I should carry this down, plus cx plus d. Okay, we multiply, we get b plus ak x squared, and then here, just be careful, we have minus, and then we have to multiply by k. So we have bk plus ak squared x then. And again we have to subtract. So again these cancel. Again this minus becomes a plus. And we're left with c plus bk plus ak squared x, and then we carry the d down. Now I know this is getting very big, but the good news is there's only one left, because we have only one left to one multiplication left to do. So it's plus c plus bk plus ak squared is the last one. Multiplying, and we get c plus bk plus ak squared x minus, and then we multiply by k, ck bk squared ak cubed. And finally, when we subtract, we'll be left with whatever the remainder is. So the remainder equals d plus ck plus bk squared plus ak cubed. Or in other words, the remainder, the formula is ak cubed plus bk squared plus ck plus d, which is kind of a long formula, but if you look at it carefully, you can see it looks familiar. What does it look like?
It's something like AX.
It's like the original, ax cubed plus bx squared plus cx plus d, except the x is replaced with k. So we can actually write it like this. And this is actually the result. This is the formula for the remainder. The formula for the remainder is actually the cubic itself, which is an interesting result. So the formula to find the remainder is the original cubic equation, which I think is an interesting result, that the formula is what you're provided with at the start. So I'll explain this with an example. So I'll just give you a moment to write this down. This proof is not on the exam, but these proofs are really good practice. This is excellent practice of long division, because if you can do this, then you'll have no problem with long division in the exam. So I would like you to write it down, even though it's a proof that's not on the exam. I still think it's good practice. So I'll just give you a minute here to write this down. Let me just clean that up a little bit. Oh, you're not cold, are you?
No, like, I saw the air, like,
Okay.
for me.
Alright. Can I scroll down now? Yeah. So can you check your notes for the first long division example I did? So what was the first long division example I did? What was it? Can you look?
The first one?
The very first one I did for you.
The 36x squared cubed
36x cubed
minus
yeah,
59x squared
59x squared
minus 25x.
You want to pass through?
No.
Oh, you're just getting something. Okay. 59x squared.
Minus 25x.
Yeah.
Minus 2.
And what did I ask you to divide it by?
X minus 2.
X minus 2. Okay. So the way the remainder theorem works, it says the remainder should equal the original, but instead of using x, we should use 2, positive 2. Because if you look at my result, where's it gone? Here we use k, and the original was x minus k. So in other words, you use the opposite sign. In other words, remember what I showed you at the start about the converting? You need to convert this. So instead of using x minus 2, you use 2. If it was x plus 2, you use minus 2. What about if it was 2x plus 1?
Minus 1 over 2.
Minus 1 over 2 is what you would use. Okay. Now, what was the answer for the remainder in that example?
0.
It was 0. So let's see if we get 0 using this formula. 36 times 2 cubed minus 59 times 2 squared minus 25 times 2 minus 2. That's 36 times 8 minus 59 times 4 minus 52 when you put these together, which adds up to 0. I'm just going to pretend I did that in my head. Yeah, so 0. You can confirm. Great, great. So the remainder theorem is a much quicker way to find the remainder. In the exam, sometimes they will tell you to use the remainder theorem, and sometimes they will tell you to use long division. If they don't tell you, it's your choice. But you should look at how many marks you're getting. For example, if you're only getting 2 marks, then you shouldn't waste time with long division. You should just use this method. But if the question had maybe 4 marks, maybe there's a reason they wanted you to use long division, because maybe the next part needs the answer from the previous part. So my advice would be to look at how many marks you get. A small number of marks means you probably want the remainder theorem. A bigger number of marks means they probably were picturing you using the long division. Okay? So just it's worth remembering that for the exam. Now let's have a look at some more questions, but just before I do some more, let me just give you one to try. Can I scroll down? Okay, give me the remainder for this one. 8x cubed plus 14x squared plus 5x plus 2 divided by 2x plus 1. I want to know the remainder. Calculate that. Is it? Let me check. Yep. So when you put in minus a half, hit that in on the calculator, and out comes 2. So the remainder will be 2. No need for long division, it will be 2. No, there's more to it than this. If only it was this easy. Okay. Can I scroll down? Yep. Right, here's another example. X minus 2, so write this one down. X minus 2 is a factor of px cubed minus 21x squared plus 23x minus 18. Find P. Because x minus 2 is a factor, that means you know the remainder is 0. So that means if you use the remainder theorem, that means P times 2 cubed minus 21 times 2 squared plus 23 times 2 minus 18, that should equal 0. So that means 8p minus 56 should equal 0 when I put this in on the calculator. So then p must equal 7. So it was 7x cubed minus 21x squared plus 23x minus 18. Okay, write this one down. I'll give you one like this to try. You wrote this down? Can I scroll down? Yep.
What's R2?
Remainder theorem. Okay. Try this one. The remainder of x cubed plus px squared plus 8x plus 14. The remainder of this is 2 when it is divided by x plus 2. Find p. So, here what I want you to do is find p. I tell you that this divided by this will make 2. And that's enough to find the p. It's very similar to the last ones. Try and find p for me now. P is 3, is it? Yep. Let's have a look here. So again, by using the remainder theorem, two cubed plus 2 squared p plus 8 times 2 plus 14, that should equal 2. So what's that? That's going to be 4p, 8 and 16 and 14, is it? 38? Should equal 2. So 4p should equal minus 36.
Why did we not switch to negative 2?
What's negative 2?
This is wrong.
Oh, sorry. Plus 2. I should have put in minus 2 here. Thank you. Minus.
Yeah.
So it's just the 38 here I need to change.
Minus 10. 4p minus 10 equals 2.
Hang on, I've got two different answers, so just 1 sec. I'll check it. Right, minus 8 minus 16 plus 14. Minus 10. So 4p equals 12. And p equals 3 then. That's the p. Okay. Could p be 0 in this one? Yeah, p could be 0 in this one. In the last one, could p be 0?
This one? Could p be 0?
That's what I said.
No, it can't.
No, yes. Any other opinions? Maybe? Yeah.
To get the remainder at 0, you mean?
No, just imagine the answer here was 0 for p, for example.
Yeah.
Acceptable or unacceptable?
Acceptable.
Yeah, because nothing about the remainder theorem needs it to be a cubic. It still works if it's a quadratic or a linear. Nothing about the remainder theorem it doesn't have to be cubics. It can be quadratics, it can be linears, doesn't matter. Okay? It's just in my proof. Back up here. This proof still works if a is 0. Nowhere in this proof do I divide by a. But if you remember the proof we did last week of this formula, I said the a can't be 0 because it's not a quadratic, but also because we can't divide by 0. In this proof, A, B, C and D, they could be 0, except the only exception is they can't all be 0. Otherwise, what's the point? But any of them could be 0. Right. Let me give you another one to try, a little bit harder now.
But could you just scroll
Oh, sorry, you need to write this one down?
to the question?
This one?
Okay.
Yeah?
Yeah.
Okay. Can I give you another one to try?
Yes,
Yep.
please.
Okay. Three x plus 4 and 2x minus... No, give you a different one.
Are factors of px cubed.
Yeah, I want to make it a...
When px cubed plus 17x squared.
Your teacher is extremely tired. And it's not even lunchtime. I need to keep some energy for the rest of the day. 3x minus 2 and 5x minus 3 are factors of px cubed minus 19x squared plus 6x plus q. I want you to find p and q. It's a little bit harder than the last one, but it's still the same idea. Because they're factors, the remainders are 0, both of them. That's enough information to find p and q. See what you can do here. Find p and q.
Numbers are terrible.
Fractions. Tasty. Oh, hang on a second, Puang. You definitely can't stay there. You're Vietnamese, and so are you. No, this won't help your English. You're definitely going to have to move soon, okay? It's better for you. We'll find somewhere. I need to put you beside someone who uses a lot of English.
Yesterday you told us to stay away from me.
I was only joking.
Look, the calculator they said as far over here.
No, I
has
already
the
ordered
same
it.
function.
I already ordered it, and it's coming on next.
Actually, yeah, no, that would be great, because the two of you, so much blah, 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 blah. You, move one spot over.
Thank you.
Yes, yeah.
Thank you. I was like,
No.
No, you can ask Andrew for the calculator.
When you
that they
finish
use
tomorrow,
on
you
his
can
laptop.
sit between
It's not
those
on
two.
the laptop. Yeah.
I'm staying. Listen,
Then don't ask.
your English will improve so much between the two of them, listening to them.
Don't anger me.
I don't know. You can listen. you'll have a lot to listen to. You can be with your friends after class. Trust me. On this you can trust me. Look, they even left some biscuits for you to have. Isn't that nice? In the middle, so you can hear both of them. And I'm not too keen about you three still being close together. And yeah, we're not too mixed up at the moment. We'll have to work on that. Okay, are we nearly finished this one?
Yes.
Yeah. Finish this one? Yeah, you got P and Q? Were they nice numbers or were they fractions as well? Were they fractions? They were nice numbers? Alright, let's have a look at this. So, remainder theorem, firstly. P times 2 over 3 cubed minus 19 times 2 over 3 squared plus 6 times 2 over 3 plus q. What should that equal? 0. 8, yeah?
Could we make q 0?
What do you mean?
Like, we make q 0.
But why?
Because you said any number can be 0, so we make q 0 and then...
Wait, so I said what now? Any number could be 0?
you said that the left is 0? Oh, only A, B, C, D. Isn't q D?
Yeah, but what I meant when I said it could be 0, meaning not that you could make it 0, but the answer could be 0. Yes, yeah, there's a big difference. Right. Oh, you thought you were on to winning super fast way to get the answer. Yeah, okay. No, sorry. You know what they say in maths? If it was too easy, it means you made a mistake. Yeah? Right. Okay, so what will this equal? Let me see. 2 divided by 3 squared times 19 minus 12 over 3. Did you get 28 over 9?
No.
No? Rats. No, not this.
218 over 45?
Yeah.
Hang on, let me try again.
What?
Not 28 over 9? When you take these two to the other side. No, what did you get over there?
I didn't get the 40 also.
19 bracket 2 over 3 squared
It's minus.
minus 6 bracket 2 over 3.
Okay.
Sorry, I'm having some kind of breakdown right now. 40 over 9. Can you, first equation. It's not enough to find P and Q from this one. We also have to use this one now. Okay. Three over 5 cubed times P minus 19 times 3 over 5 plus 6 times 3 over 5 plus Q equals 0. Yeah? 27 over 125p plus q equals, alright, careful now, 9 bracket 3 over 5 minus 6, oh, what did I forget? Squared. Minus 6 bracket 3 over 5 Did you get 81 over 25?
Yes.
Yeah. Now, what's the best method to use to solve these two?
Calculate
Best exam method to use?
substitution,
Not substitution.
elimination.
No, elimination, because the q is ready to cancel. Q minus q, it's gone. 8 over 27 minus 27 over 125, that's 271 over 3375p equals, and then 40 over 9 minus 81 over 25, 271 over 225 when you minus these. What can I cancel? Well, they go. So P is 3375 over 225.
15. Why not 1s
15.
and 2s and 3s?
15. What? If you have a problem, complain to whoever wrote this book. It's just me. You can leave your complaints in my filing cabinet by the door on your way out. Just leave it right in there and I'll get to it as soon as possible. Right, now how can I get the Q? Sub that back in there, so I get Q equals 81 over 25 minus 27 over 125 times 15. So let's see what I get here. Perfect example. So Q is 0, which is allowed. So P is 15 and Q is 0. Okay. I'll give you one more example we'll do together, and then you can start on some homework questions.
So if Q was 0 and I did that.
That was just such dumb luck that it worked out to be 0.
Why didn't get P as 15?
I got P with 15.
Yeah, but you should have. You should have though.
I got mine.
If you were lucky enough to guess that Q was 0 and it was, the P should have been 15. You got P as 15?
I made Q 0 and I got P is equals 15.
Okay, but you're not allowed to make Q 0. It just so happened that the answer was Q equals 0. Now, so the two of you picked my statement up the wrong way earlier. Yeah, okay. Just to be clear, not that you can make it 0, just that it could be 0. Okay. Let me give you this one. Can I scroll down? Yes? Find P and Q if 15x squared minus 23x plus 6 is a factor of px cubed plus qx squared plus 29x plus 6. Now you might want to work together on this one. It's a tricky one because it's not clear here what to do. And I'll give you a couple of minutes, see what you can come up with. So I'm looking for P and Q here. Oh, I've got that in here. Yep, no problem. Dude, turn around. I put you in the middle so that you can work together. I want to hear some cooperation. Finished? Let's see what you did. Where was it? Okay. Let's see. Where did it start? So what was your first step? This. And you put these in there here. The factors. So these must be factors. It's true, but your logic doesn't convince me. So you're right. These will also be factors because this is this, and these are factors of this. Why? Yeah, but why if this is a factor of this, why does it make these factors as well? Yeah, but just because this is a factor doesn't mean each of these are factors. Maybe you need both together to make a factor. Do you know what I mean?
This? I'll try to understand.
You get what I'm saying? Yeah. Now you're right though. It is true that these are factors, but I want to know the justification. So have a think for a moment. It's right, but justified.
No, it's this one.
When you get your calculator. Maybe. Amazon. You went to another country without a website. No, you can't. Okay. Have we got answers?
Well, I think we can.
You didn't make Q equals 0 again, did you?
No.
No. Get it strong? Yeah. Easy? Hard? Did he get it? Did you get it?
I'm getting it, just a second.
Okay, we'll have a look at it now. So the first thing, we can factorize this. So instead of writing 15x squared minus 23x plus 6, we can say 5x minus 6 and 3x minus 1 is a factor of px cubed plus etc, etc, etc. Now, just because this is a factor doesn't really help us. We need to know if both of these are factors. So let's just pick an example with numbers just to double check our idea. Huh? Yeah. So we know that this together is a factor of the cubic. But that's not helpful. We would love to know, is this a factor and is this a factor separately?
Isn't it as long as they're factor?
Well,
Smaller factors.
well, this is what everybody is saying, yes, and that's true, but you have to give a reason why. Just because this is a factor doesn't automatically mean that each one is a factor, because as I was saying to someone else earlier, maybe only both of them together makes a factor, not each one separately.
But division and multiplication, so
Yeah, so you need to give some justification. So for example, suppose I say that 6 is a factor of 30. 6 can be written as 3 times 2, and that's a factor of 30. Is 3 a factor? Is 2 a factor? Yeah, so what's happening is, if you say 6 is a factor of 30, that means you can say 30 must be 6 multiplied by some number. That's what it means to be a factor, that 6 goes into it. Yes? So you can say 6 is a factor of 6 multiplied by some number. Now in this case, what's this number? It's 5. Yeah, 5, yeah. 6 can be changed into 2 and 3, and 6 here can be changed into 2 and 3. So you have 30 is 2 times 3 times x. Here 6 is 2 times 3. So yes, 2 can go into this. 2 divides into both of them, and likewise 3 can go into them. So it is true to say, if these are both factors multiplied together, then each one is a factor. The reason is we can pull the quadratic out of the cubic and be left with a linear. This quadratic is the same as this quadratic, which is the same as this. So 2 of the factors here are these 2. So it is justifiable. You probably don't care about that, but I felt it was important to explain why what you did worked. So if these 2 are factors, it means you can say P times 6 over 5 cubed plus Q times 6 over 5 squared plus 29 times 6 over 5 minus 6 equals 0. And then here P times 1 over 3 cubed plus Q times 1 over 3 squared plus 29 times 1 over 3 minus 6 equals 0. I think everybody wrote that down, did they? Yeah. Okay. So I'm not going to finish it because it's exactly the same as my last example. Once you got to this step, you've made it the same type of problem as what I did earlier. The same deal. So all I really wanted to know here was, were people able to go from here to here? And it looks like most people were. Yeah. What answers did you get for P and Q?
minus 15 and 38.
Go on, Fuan. What did you get? P equals and Q equals. Is that what you got over here? See, if you work together. Okay. I'll let you work on these for a few minutes. So the homework questions are, let me write them down here. 1A, 2A, 3A, 4A, 5A, and 6A. A from each, yeah. You can work on them now for a few minutes before the next lesson. Question? Yeah, what could you write? For the exam, you don't need to, but I just mean for practice work is good. Just for understanding, yeah, for general understanding, and inclusion of your mind. So let's say, I don't know. I can write here. What way will I write down? So I want to say something like, let's just say fx is a factor of gx. Let's just say something like that. And we can also say fx has two factors. We'll just call it ax and bx, whatever we have. So these are the two things we have to start. So we can say that means ax, bx. I'll number these here, 1 and 2. Okay. So from number 1, if this is a factor of this, the definition is that means gx can be written as fx multiplied by something else, which I'll just call it, I'm not using h yet, how about h? So that actually is the definition of a factor. If you're saying that this is a factor of this, it means that you can write this as the factor multiplied by something else. That's the definition. But from number 2, you can say that gx, fx has ax and bx, so that means you can say gx equals ax, bx, hx. And then what you can do is you can say something like call bx, hx, we'll call it something like whatever that is, ax, we'll go with kx. So now this becomes gx equals ax times kx, which is the same as saying ax is a factor of gx, because the definition is if you can write gx as ax times something else, then ax is a factor. And then you can say likewise bx is a factor of gx. So this is what I mean as some kind of justification formally for what you're doing. No, this is beyond what would be used for the exam, but I just think it's good to think about these things from time to time. Because I know the natural instinct would be, well, it has to be, obviously, but sometimes it's not always exactly what you think, unless you have a bit to think about it. Does that make sense? Yeah. And actually, if I really want to be a bit more formal, I should really put my arrow like this, because it really is the same as, if this is true, then we say it's a factor, or likewise, if it's a factor, then we can write it like this. So you can make the language a bit more formal as well. Okay. Yeah.